Brother Smith here with ECEN106 Computer Systems. This is the video I promised you about coding and illustrating some of the different steps for how to do that. So I've got a Linux computer right here that I'm logged into called Death Star, and I'm in a folder on my home directory called ECEN106/coding. And if we look at this listing of the directory, there's nothing in here right now. Okay, so I have these special directories, but there's no files. So we're going to start right from scratch and show you everything. We're going to take you right through all of the different steps. So, we're going to pseudocode, and then we're going to write our program in a high-level language and compile it and assemble it, and then actually end up running it all in the end. So we'll walk you through all those steps so you kind of see what each of them looks like. So the first thing we want to do when we develop a program is to write some pseudocode, right? Some description of what we're going to do. So I'm going to use my favorite Linux editor, Nano, and let's just call our program hello, and I'll call it like hello.pscode for pseudocode, right? So I'm just creating this file. So our program, what we want to do is just display some text, hello world, on the screen. That's what we want to do. And then after we display the text, we want to exit the program. So remember, pseudocode is just a description of what we want our program to do. It's a really plain English what we're going to do, right? So this is what we want to do: display some text and then exit the program. So let's save that and exit out of that. And if we take a look at this program, we use the command cat to look at hello.pscode. And then we can see this is what we wrote in our code, in our file, right? So that's what we want the program to do. So the next step is to take it from pseudocode to some high-level language. Okay, so I'm going to use Nano again, and let's use a different file this time. We'll call it hello.c because we're going to write our program in C. So Nano will open up with a new file called hello.c, and now let's write our code. I always like to start out with a comment that tells me what this program does, or what this program is, right? So this is hello.c. And then in regular C, and I'm not going to go into description of how all the different C commands work, but we need to have a main function, so we'll call it int main with no arguments. And then inside our main function, we're just going to print f hello world. Like that. We also want it to go to a new line, so we'll use a special character, \n, to do that. And then the next thing in our pseudocode was to exit out of the program, right? So to exit out, we're going to just return 0. And that's all we need to do in there. Now, because we're using this printf function, we need to include some other stuff because C, the compiler, whatever we're going to do with it, doesn't know what printf does. So we need to include another set of instructions. And that other set of instructions is another file actually called standard.io, stdio.h. So we're going to include that program in our program, include that file in our program. Okay, so this is our C program. This is our high-level program. We can take this to any computer and compile it on whatever computer we want to, and it will print hello world. Okay, so let's save that and exit out. And now if we look at the directory, now we have a new file called hello.c. We can display that file called hello.c. And there's our program. Okay. Now, the next thing we need to do is pre-compile it or run it through a preprocessor. And what the preprocessor does is take that standard.io file that we have sitting out there, and it will combine it with our hello.c file so that we have just one file with everything together, right? So to do that, we're going to use GCC on Linux. That's the GNOME C compiler, GCC. GNOME, some people say. So we're going to use GCC. And if I were to just type GCC hello.c, it would do everything and compile it right to an executable file for us. And we could do that, and we will in the end. But for now, I want to stop it at each little place along the way so you can see what's happening. So in order to do that, I'm going to use some arguments. In this case, I'm going to use a -e and then send it our program. And then the -o is going to allow me to change what the output looks like or what the file name of the output looks like. I can write it to a different file. So I'm going to write this one to hello.pre for pre-processing. Okay, so let's run that. Now if I do a listen to my directory, you'll see this new file, hello.pre. Okay, so if we look at that, you can see that we have our program down here at the bottom, right? But then we have a bunch of other stuff in here. Well, this other stuff came from that standard IO file. So now it's combined everything into one file. All right. The next step is to actually compile the program. When we compile this program, this pre-processed file, what we're creating is our assembly code. Remember, assembly code are those short English word phrases, words or phrases, right? Like load or move or add or subs, things like that. So this compiler is going to take our high-level language and convert it into a language that our processor understands. And this machine code or assembly code is very specific to the processor. Okay, so if you can't take this assembly code to a Macintosh or to an Apple computer or some other type of computer. Any Windows computer will work for the most part, but maybe not 16-bit, right? You got to have a 32-bit program or a 64-bit or something like that. Anyway, we're getting kind of deep. The point is, this is machine specific. Okay, so this time we're going to use GCC again. We're going to use a -s for our argument, and we'll still start with our hello.c program. And this time we're going to output it to a file called hello.asm for assembly. Okay, so let's run that. And then let's take a look at this. So we'll display hello.asm. And now you can see our assembly language. Okay, so there's our file name. It says file. We have this string called hello world that we're going to output, right? Here's the commands. Push Q, move Q, call Q, move L, pop Q, there's a return. These are the short English words or phrases that we're used to seeing, okay? Align, whatever, okay? So this is our assembly language. Now we've converted our program from pseudocode to a high-level language C now to assembly language. The next step is to assemble this assembly language into the zeros and ones that our computer understands, right? Some kind of, we call it object code or machine code. So to do that, we're going to use GCC again. This time we're going to use a -c argument with our original program, and we're going to output it to a file called hello.obg, obg for object or object code, right? So we'll do that. We'll do a directory again, and you can see our new object file right here. And then let's display that. That's weird. So we get a beep and a bunch of garbage, kind of. If we scroll up a little bit, we can see, so here there's a bunch of stuff it doesn't understand. There's a little bit from our program, and then a bunch of gibberish and stuff. Well, why is that? Well, this object code is just a bunch of hexadecimal characters, hexadecimal bytes. And our display doesn't know what to do with them or how to display them, right? So we have to use a special program. I'm going to use a Linux program called XXD, which is just a hexadecimal editor, a hex editor. And let's look at that file. So this first column over here is just the location in the file, right? So this is location 0 right here. Here's location 16. Remember, this is hexadecimal. So we're counting in hexadecimal, so 10 is 16, not 10. So this is position 16 right here. This is position 32 right here, okay? And you can see out on the last column kind of a real-world description of what those hexadecimal values are. It's doing its best effort to display those. So like if you look at a 00 right here, it doesn't know what that is. It just puts it in as a period, as a placeholder, right? F3 on this line doesn't have any displayable character with it, so it just shows that as a period on the output line. The actual file only contains these middle 8 columns, okay? It doesn't have pointers out here or a real-world explanation. You only see the hexadecimal values in these middle 8 columns in that actual file, okay? So that's why our screen doesn't really know what to do with them sometimes. It knows what a W and an O and an R are, but it doesn't know what an F3 is, okay? So here's our object code. All right, the next step is to link this object code, this machine code, into some executable type program. So we're going to use GCC again, but this time we're going to use no arguments, and this is going to take our hello.c high-level language all the way to an executable. It's going to link this machine code to the zeros and ones that are actually executable and runnable on the computer. So we'll take GCC, we'll put our hello.c into it, and we want to output some executable things so we can see it. So we'll just do hello.exe. We look at our directory, you'll notice that hello.exe is a different color. On my system, green indicates an executable program. You can see the X's over here. That means it's executable for different users and groups and stuff. And so now we have a program we can actually run. So let's do it. We'll do hello.exe, and there we go. It displays hello world for us. So again, we've taken our pseudo language, pseudo code description of what we want to do with our program, type something to the screen. We created a high-level code of it in C. Then we pre-compiled that. So we combine all of the files together into one. Then we combine all of those. We compiled those into some assembly language code. That's the short English words or phrases there. You know, the load, sub, add, move, whatever. And then we assemble our assembly language into machine code or object code. That's the hexadecimal stuff that we see here on the screen. And then we link that object code to some executable code that we can actually run our program with.